All right, so now I'm going to show you how to use the PID tuner. Right, to use the PID tuner, you need first to construct the plant. I mean the transfer function of the plant. Here's a sum code. Right, we defined or we give values for M, B. Right, so those are the parameters of the vehicle. Now, you use the command TF to create the operator S in S domain. Then you just literally type in this transfer function, right? 1 over ms plus b. Then you use the command PID tuner, right? The argument for this command is the plant itself, right? The plant is a transfer function. Right? This command is case sensitive, right? You need to use the capital T. And there are some other options for this command. You can use help to figure that out. You can see, you will see some other options. Okay. For now, I'm not going to worry too much about these options. Once you run this command, the PID tuner will come up, right? So this is the interface of the PID tuner. And there are some drop-down menu from which you can configure the PID tuner. For example, you can import a plant. If somehow you did not give the argument to the PID tuner, you can change the type of controller. You can use P controller, I controller, PID controller, or PI controller. So here, the type is the PI controller, which is what we want. You can change the design this PI controller in time domain or in frequency domain. You can add some plot, for example, body plot, etc. In the middle here, you can see 2 sliding bars. By dragging the 2 sliding bars, we can adjust the parameters of a PI controller and hence the system response, right? So for example, you can drag this handle, you will see the system response is changing. We will come back to this in a second. Right. We will adjust this so that our requirements can be met. In the main body here, it shows the step response of the closed loop system. And this is not the plant itself. This is the closed loop, the step response of the closed loop control system. By clicking on these show parameters, you can see some important parameters, such as what's the current PI, KP, KI, and KD, etc. You can see the rise time, settling time, overshoot percentage, etc. Okay. So we will use this. So you need to keep this window visible. Now let's come back to the sliding bars. Okay, so there are 2 sliding bars. So in the top bar, we can change the response time. Right? In other words, we can make your system. You can make your system faster or slower by dragging the float handle. Right, just like this. You drag it. If you move it to the right, it will go faster. And there's other ways. For example, you can type in some numbers here, right? You can type in numbers, it will change, or you can use this up or down arrow to tune this to tune the system, become faster or slower. You can also quickly change your system become more faster or slower. So by click on this double arrow, so this will change the system by a factor of 10, right? You can go faster. You can see your system become much faster, right? The settling time is 0.2 seconds, or become slower, just like this, right? We'll make change. right? You will see the settling time, overshoot percentage will change. All right, in the bottom here, you can, bottom sliding bar here, you can change the transient behavior of your system. You can make it more robust or more aggressive. Well, in general, when you make your system respond faster, the overshoot may become larger, which may violate your requirement. For example, if you are the current overshoot is about 20%. If you make your system a little faster, so the overshoot will be increased. Now you can change the transient behavior of your system. If you make it more robust, and the overshoot will decrease. At the same time, your setting time or red time will increase as well. Right? Just by working on these two sliding bars, you will find a point that all our requirements can be met. Once it's done, you can take a record. You take a note of KP and KI, because we will use that later on. You can export the designed PID controller. In this case, the PI controller, right? You can name it. By default, the name is C. So now you click OK. You go back to your MATLAB. You will see there's a variable C in the workspace. Now you can show them, right? So this is a continuous PI controller, right? It's a controller object. If you want a transfer function, for example, you want this transfer function, you can use TF command to convert it to a transfer function.